On number 7, they want us to calculate the area under the curve, this time using both left and right Riemann sums. Number 7 is sine inverse of x over 3 from 0 to 3, and they want us to use 6 rectangles. So the width of each rectangle, if we take 3 minus 0 over 6, we get 0.5. So my graph here, if you graph it on the calculator, make sure to use Radian Mode, and it's not very high, so you could set your, set the x values in the window from 0 to 3, and you could set your y values from like 0 to 1 or 0 to 2. But essentially the graph shape is very similar to just kind of a normal curve. So I want to show my intervals here. And 1, 1.5, 2, 2.5, and 3.0. And let's first do left triangles. So the first left triangle, it's not going to even really be a triangle because the graph is 0 there. And then this one's going to be like that, and so on. So the left Riemann sums, it's always your left corner that hits the curve. So another thing about this one is that when we calculate it, it's going to have to, we can't get our decimals and add those up because that would be way too much rounding. So we're going to actually type in the function a lot of times and then only round once at the end. So it's a lot of typing on the calculator. But you would take the width of each triangle, which is 0.5, and then I'm going to multiply by 0 plus 0.5 times the height of the second rectangle here. That's if you plug in 0.5 into the function. So I want to actually plug in 0.5 into my function. So times sine inverse of 0.5 over 3. And then add 0.5 times sine inverse of 1 divided by 3 plus 0.5 times sine inverse of 1.5 over 3 plus 0.5 times sine inverse of 2.0 over 3. Again, we're doing this because we only want to round once at the end. Otherwise, our answer is going to be way off if we keep rounding on each of these numbers. So this should be equal to, let me put this up here. So if you type this into your calculator, then you should get 1.373 as your estimate. Again, this is going to be an underestimate of what the actual area is because of all of these gaps here that we're not accounting for. Okay, so that was with the left triangles. Now let me erase this so I can do it with the right triangles. I'm sure that there's like a clear all button on this app that I'm using, but I can't find it. The width is still the same, so the only thing that we're changing is that it's right Riemann sums. So same curve. Let's see if I can do the spacing again. 0.5, 1, okay, so with it being right Riemann sums, the right-hand corner needs to touch the curve. That doesn't look quite right. There we go. Okay, so when I'm calculating my values, this is going to be 0.5, and I can always write it as just 0.5 times each of these. I don't need to keep writing 0.5 every single time. So I'm going to do sine inverse again, you're plugging in these values into the function. And we don't want to round every time because that would be way too much rounding. Okay, so if you add these all up and multiply by 0.5, then your answer should be 2.158, which is an overestimate because all of this areas here are above the curve and we're overcompensating. So the actual area of this is going to be somewhere between this 2.158 that we got here and the 1.373 that we got from the left Riemann sums. So somewhere in between is definitely a good bet for the actual area of this.